Let's see if this automatically starts streaming. And it does, even though I was supposed to have it hit the button, but apparently I'm streaming early. That's good. So today we're going to be working on some uMyo machine learning stuffs. And as you can see, all of the stuff on the desk, this is what I've been doing this last week. So have some exciting news. But today, before we get into anything, we're going to be working with some certain modules. So, as you may or may not know, I'm the creator of openMuscle. It's a pressure sensor forearm bracelet that I was able to successfully detect finger curls and not just whether or not it's curling, but different levels. But we recently are working with uMyo and doing the same thing because the same process can be applied to pretty much any forearm bracelet that's measuring muscle signals in one way or the other, because we're going to use some supervised machine learning. Hello, Joe. Supervised machine learning to be able to tell the computer or tell the model what exactly we're trying to train it for, and it's to predict certain outputs. So we're going to supply it with the inputs and the outputs. But in order to do that, we have to do some interesting stuff. Like, a lot of transmission protocols are interesting, and we're dealing with pretty, when it comes to programming, is a pretty quick um, um, data signal you have to process. I did not win the Hackaday competition, no. And I'm not sure why I wasn't even in the top 10, but that's okay. They must have, for some reason, decided not to, which that isn't necessarily a bad thing because I got the recognition that I needed to just let people know this project exists, because there's, really, I'm just releasing this information for free and making sure that people that search for it can find the information if they do that, because I do some search engine optimization. But yeah, so we have some exciting stuff. We're going to be working with uMyos today. So I had started to write a library for it, and quickly things have gotten pretty messy in the code. So I'm going to have to beautify some of that code here. And let me close my programs that I had running real quick. I want to save the file. Oh, wait. Oh, darn. There was a file that okay. It was a good thing that they asked me to save it. That was part of the diagram I was going to use today. Maybe I can open that back up. One second, guys. openMuscle is for real on another level. Thank you. It is my passion. I spent a year, a little bit more on it. Now I'm really excited to work on uMyo, because any forearm sensor can do this. And I think the beauty of AI or machine learning or deep learning is that it can really benefit society. And I was watching a good podcast today. They're talking about how we're going to probably have to reinvent our economy because of the amount of work that AI will be able to do is just going to change things as we understand them. I'm pretty sure. That's from my limited experience. I'm not trying to be a doomsday or whatever. It's not the dooms. It's actually kind of the opposite. It's kind of optimistic, I think. And that's why openMuscle has been so fun to work on. So let me close all of these. Oh my goodness, I didn't realize how many windows I had open until I started to the stream a little early. Okay. Now I can pop open my browser. And so let's go to the desk. Basic income is going to happen. I really do think so. Yeah, I think I've talked to people on with different political beliefs, and they pretty much say the same thing. So what we're going to be working with today is ESP32. So Joe, I do believe that you were talking about you wanted to receive the information on an ESP32 and to the computer, if I'm not mistaken. Now, in order to do that, you're going to need an RF chip. And so this is the NRF 24L01. I'm just barely familiar with it. What I did off camera, so as not to bore you guys, is I made this JST jumper, because there are a couple of rows of pins here, and when we put them on the board, it would actually short them out, or not short them out, connect them. So I had to make this handy dandy cable. And this, I just wanted to show you, was the work I have been doing some design work. But this week we're going to be focusing more, and not on mechanical design, but more on the code. So I'll show you guys this. So this is a device I'm working on with Ultimate Robotics. It's just a modified version. We're going to have, hopefully the hardware looks pretty cool. And so I've been spending time with that, but we need the code right now to do the ESP32, so we're going to need to use this LASK system. But instead of worrying about this, because this will come soon, I think we should focus on the code that actually talks about, that can receive the data on an ESP32. So Joe says, yes, want to connect uMyo ESP32 with BLE and then connect ESP computer via cable. Well, I don't think the ESP32 can actually receive. Oh, so you're going to do Bluetooth. That's one thing I can't do. I can't tell you how to do Bluetooth on an ESP32 because this ESP32 does not have Bluetooth in it. I use MicroPython. I do have a couple of boards that have Bluetooth. I'm pretty sure this is one of them. No, that's a C3. Well, the C3 does. We could use a C3. But I don't program in Arduino. Yeah, the ESP32 has built-in Bluetooth. Yeah, the problem you're going to run into is that there's so much latency, right? So the latency from the Bluetooth to the ESP32, I just don't like to muck with. And that's so heavily, it's so much computational power too. Depending on your ESP32, you might run into issues. You're going to have to optimize your code by quite a bit. But the easiest and quickest route is just to use this module. And I think this module is probably the most preferred for real-time streaming of the data. And that's the NRF. Oh my goodness, I'm going to have to look this up again. NRF 24L01. And Arduino, because ESP2, yeah, it has built-in Bluetooth. No, let's take a look what this says. So I looked up online. These are the MicroPython drivers here, but this is the NRF 24L01. Very inexpensive board. You can use it to receive the radio frequency that the uMyo sends out. Bluetooth is so complicated. I just hate Bluetooth with a passion. I literally do. I'll just make that statement. Bluetooth is not good technology. And I only feel this way because most of the time Bluetooth just fails at actually improving upon its predecessor, right? So anytime a protocol or something fails to improve upon its predecessor, and it still doesn't do all the capabilities of its predecessor, it's a failed technology. So Bluetooth should just be rewritten, in my opinion. But I'm actually going to try to do that. That's one of my stupid projects that I have. So yeah, so I was going to work on actually receiving it. So this is what we want here. Copy this image. So these are the cables that I have. And I can't put both up on screen, but the VCC, CNS, MOSI, IRQ, MISO, SEK, CE, and ground. But before we get into that, I think what's even more beneficial, because I don't know if I was going to do this today, is looking at the code for recording the uMyo into a text file. And I think that's what we're going to want to do. I think that's what we should do first. I'm going to have to pull up the GitHub repository. And we'll see. I didn't really plan anything, so please forgive me. I'm pretty spacey when I work on things. Ultimate Robotics, uMyo, Python tools. Okay. Yeah, well. Okay. So we'll get this, and we're gonna open with GitHub Desktop. I don't have GitHub Desktop? What? Oh wow. My hard drive crashed, but that's okay. We're just going to we only need that to look at the code to modify it. So I need to get the newest version of uMyo. We're going to download the zip. Okay, it's downloading GitHub. So open this folder. uMyo zip. There we go. So we'll open this up. And we'll paste it here. And of course it went somewhere odd, is my guess. So we'll start with the base version. Oh, you guys can't see this. That's probably not very helpful. Okay, so we have this base version of uMyo. And now I'm going to pull up I'm going to pull up the other folder here. And see where I put uMyo. There we go. So this is the other one that I have that I made. So uMyo test. Let's see where that one is. 3-channel detector. Oh no. Please tell me that okay, good. My hard drive didn't crash completely. I still reinstalled some stuff. Okay, so we have the uMyo 3-channel detector. No, that's not the one. uMyo testing. uMyo tools, serial port open, display stuff. So the first thing I have to do is remember where I left off. So I remember this. This is how we're doing the machine learning here. Okay. So I'm going to save this into desktop. Thank you guys for being patient. So this will be test. Test underscore. No, it should be a. This is a horrible file name. Okay, so an AAA. So now we can see that it should appear here. Yeah, so machine learning train. So these are the files that we want. Okay, then we have the packet filter. Oh, wow. That's really helpful. Yeah, I need to install GitHub. Oh my goodness, guys. I'm sorry. I feel so bad. I think I lost some of the progress that I made possibly, but we will find out here shortly. Yeah, I thought I had GitHub. Yeah, I have GitHub. Okay. Installation has failed. Good. I didn't want the installation to continue anyways. So now we can do the proper pulling. So this is I'm going to sort this by newest, actually. modified uMyo testing. So it looks like I just used display stuff. I'm pretty sure. Yeah, I did. So I modified display stuff. So we're going to have to name this something else. So what I did is I found the code in here, as we'll see. Yeah, so the file number is captured. So this is where the program starts. So recording file. So it opens up the recording files. This isn't a very good method of doing it. So that's kind of why I didn't want to post this online. Doing the calculations, the drawing. Packet plot repair. There we go, right here. So this is where I add the data from the packet. So I'm just taking the QSG values, the 4 of them, and we'll put that there. So this is file output parameters. No, variables to add to I think it's a dictionary. Okay. So I could technically pull this data from here, but I think I'm going to leave it. So we're going to save this as, this is going to be so horrible, AA 23 underscore display stuff. But I'm going to put it with the other documents. Okay, so now we have this one. So we're going to have to use, and then machine learning train. We should have, okay. Show more options, fresh, display stuff, machine learning train, and we also need packet filter. I think I made it into a new folder. Yeah, data captures. Okay, so we're gonna have to capture, copy and paste data captures. And yeah, so then we have the packet filter. And most of these shouldn't be too big, so I'm gonna make a new folder and then dummy data. This is just a backup of files, just in case someone wants to poke around. I'm trying to think of a name for it. Just test data. Just name that, and then we can put everything inside of it. It's all we need is packet filter. Okay, so packet filter. So we're going to rename this into AAA underscore packet filter. Okay. So now we have that. Let me. Where the heck is GitHub? How many times have I opened up this app? Where is GitHub? Chrome has a billion tabs open, but where is GitHub? Oh, silliness. I have After Effects running. Oh, I didn't even realize that. Well, end that task. GitHub. Fine, I'm gonna reinstall GitHub, I guess. Oh, what a wonderful little excursion here. This is the joys of working on with computers. Sometimes you have to reinvent the wheel. So while that's kind of loading up, we can. So this is the last system, and we're going to be hopefully able to send a similar data type over the radio frequency. But for this test, we are going to be using the old LASK system, which I might have dropped somewhere. Here we go. And these are using the same batteries. I might have lost the battery. So this is the new, I think this is the one that fits. It is. This one fits better than this one. Yes. And this one should clip on to the top of this, because this is the same thing. So I made this pretty well to stick on. There we go. But it still snaps off. So it has some ridges inside of there. And I have an even better one that I made that has slip-on ridges. So that can just snap right on, but there we go. This is the old one. So we are going to take apart this and put it on the other one. Okay, there we go. So we're in uMyo tools. Good, good, good. Ultimate Robotics code. Open with GitHub Desktop. Open with GitHub Desktop. Okay, so uMyo Python tools. 11 changes. So I do have that structure. Perfect. So I can come in here and copy all this. You guys can't see this, thankfully, because otherwise I'd be embarrassed. I'll put this in GitHub, uMyo Python tools. We're going to paste it all. Replace. Okay. Oh, I think this is okay. This is quite scary, guys. You know what? I am actually on Python tools. I kind of want to just delete it. Okay, and open up GitHub. clone again. Okay, so now we've cloned again. uMyo Python tools. Refresh. Perfect. Okay, so this is uMyo Python tools. We're going to make a new folder, and then it's machine learning test. Inside of here, we are going to put all of the code that we did. Wherever, there it is. Okay, so now we can paste it in here. Awesome. So it's just inside of machine learning test. uMyo Python tool summary is machine learning test. Test code. Code to test regressor on uMyo. You don't have access. Want to create a fork? I think I have to create a fork. Oh my goodness, current branch. Yes. Do right. Create fork. Fork this repository to contribute to the parent. There we go. So this is machine learning test. Basic code for using labels. I don't like to have to figure out how to put the spelling of that. Push origin. Okay. We're having fun here. Hope you guys are having fun. Okay. For a second I was like, can you guys even hear me? Okay, so now we have our own fork that has this inside. So I'm going to go to GitHub and see if I can share the link with you guys. uMyo Python tools. Perfect. So this is the new fork. So I can operate here. Oh, awesome. So now the real fun begins. Navigation pane. I forgot how boring some of this stuff is. The minutia. That's why sometimes I don't stream this stuff, because it just takes discipline sometimes. So here we go. Okay, so all that work just to get the machine learning test here. So display stuff, AAA display stuff. We're gonna have to go to uMyo test. uMyo testing. Okay. File save as. This would be AAA underscore uMyo data recording. USB data record. Okay. USB, perfect. Gonna have to refresh. Awesome. So inside of here, we're going to import not display stuff, but we're actually going to do AAA display stuff. And then we're going to utilize just the normal parser, because inside display stuff, we'll have to see. I think uMyo parser. Import sys, date, time. Oh, wow. They really don't. Plot prepare. Import anything? Oh, I didn't realize nothing was imported. Oh, yeah. Sys, Pygame, OS, math. So display stuff does not have anything in it. But uMyo parser does. Let's take a look. So the uMyo class, quat math. Okay. So we're going to save this as AAA underscore uMyo parser. And then we're going to have to do uMyo class. Save uMyo class. Cool. Then this is pretty simple. File save as AAA 23 uMyo class. What's the uMyo USB data record? So the USB uMyo data record is initiating the recording. So how uMyo is structured right now is kind of interesting. But I technically only need these 4 files, right? So all of these can be deleted. And this is just a machine learning test. Channel detector. Yeah, so these are all the files that we need. The other ones exist here because I just kind of used some of their own files in order to make this easier for myself. So I based all of these AAAs off of theirs. So how it's mainly recorded is this loop. So uMyo USB data record is the main loop here. So what this does is it imports uMyo parser, which actually I need to do AAA uMyo parser. So it will import uMyo parsers and display stuff. So let's take a look at those 2 files. So this is a uMyo parser. And let's look at display stuff. Here. Okay, let's take a look. Reading code is actually kind of fun. Will you use the USB that comes with the uMyo kit? Yes, I am using the USB that comes with the uMyo kit. And it's all set up and ready to go. So I'll just kind of run this down. If I bore you, let me know. So uMyo, AAA uMyo USB data record, as I've renamed it. And let me push the GitHub while I'm doing this. So if you're trying to follow along, you'll see the update. Trim bat from old files. It's a really horrible name, but at least I gave it a name. And it's my branch of it. Okay. So what this is doing, it's going to import uMyo parser and display stuff. So that tells you already we're going to be using these 2 files, and those are the 2 files on the right. From serial tools, we're going to import list ports, which is one of the functions in serial tools that will list whatever port is in your computer. So this is a pretty cool little way of getting the the last port because it's going to list the ports in a loop, and then the last port it's going to apply to the variable device. Then I'll print three equal symbols. So essentially, whatever the last device listed on your ports, COM ports, is going to be the USB device. And I did write some code that could kind of get around that. I don't know where I put it, but I will work on that. Actually, yeah, let me grab that. That would be really helpful. Let's edit with IDE. Yeah, I think I put that. Okay, I think I remember. 1 second. What did I call it? uMyo Python tools. Serial tests. Yeah, so this is some better ports. I'll just do this. So this is some code I wrote. So instead of from serial tools, huh? Oh yeah, it's ports. Okay. So literally we can paste this. So this will select the port. Serial equals serial, port device. So now we're going to do device equals select port and port. Huh? Why am I sending port into this? Huh. I don't know why I did that. Interesting. Let's see if this works. Invalid syntax. Okay. No module named quat math. Okay. I'll paste this into the browser. I'm sorry, I'm a little lost. The RNF module, what does it do if you're using uMyo's USB kit? Yeah, so I'm using the uMyo's the NRF chip, right? And I also have a label system that only sends via Wi-Fi. So by using this chip, I can receive the uMyo signal on this ESP32 if I plug it in, or I could also send the data from this label to the same USB receiver that uMyo uses, right? So those are the two things that this chip will give me if I plug it into an ESP32. But I'm right now, I'm just getting some of the code ready. So quat math, CMD, gonna have to see if I can install Python. Python, techm, pip install quat math. Yeah, what is that? No module. No module named quat math. Python. Import math. Yeah, so I'm not sure why this is that what it was saying? Yeah, so import math. Huh. Where is that quat math? It says import quat math. inside of uMyo parser. Quat math. Huh, I don't remember running into this. Sometimes we run into some interesting ones. Because usually what I do, okay, now I understand. You send data from uMyo to ESP32 via NRF, and send data from ESP32 to computer using uMyo USB kit. Yeah, so I am sending from uMyo to ESP32 via NRF. Sure, I can do that if I want, and then send data from ESP32 to computer. Yeah, but I don't want to ever use one device to hop another device to it, right? Because you just don't want to do that because the data has to be transmitted twice. Anytime that you're transmitting the data twice, you're doing it twice as slow, right? You're cutting your transmission speed in half. Not really, but it has the potential for that. So what I'm trying to do is have both the label system and uMyo send the same frequency. So since this talks, it can talk in Bluetooth, but I don't like Bluetooth for real-time streaming. It can talk in the radio frequency, which that's what we're doing, but this device can only talk via Wi-Fi. So if I have this device speak the same and it will send to my computer, then this will send to my computer. Now I can just use one USB stick to receive the information. And let's plug that in, actually. So this is it right here. So let's go ahead and actually plug this in. All right. And while I was doing all that prep work and talking about nothing, I forgot to undo this. And I really hope that that battery didn't fall too far. Oh wow, I had to use the longest screws in the world. Bought a whole bunch of these M2 screws because they're pretty handy if you're a 3D printer. May I ask why you're using a USB Wi-Fi stick if you're using a laptop that has Wi-Fi? This is not a USB Wi-Fi stick. This is a USB radio frequency chip. Yeah. So it's speaking on the 2.4 gigahertz bandwidth, but it's not speaking the same language, the same protocol as Wi-Fi. It actually uses its own custom protocol, which is pretty darn cool. So this is the old one. Where's the new one? Yeah. Oh, yeah. I forgot. I made this handy dandy one with the things on it. Oh, this is so cool. First time doing this. So this is probably be my upgraded prototype to include the thumb. But okay, let's get. Oh no. No, everything was blowing up. There we go. There we go. Things. Should probably have tested that this fit, but it looks to fit. Fit pretty nicely. So yeah, this is a board that I made a while back. And I'm going to be testing this on some lower tension springs. Tension's probably not the right word, but let's see how well it fits on. Oh yeah, it just snaps on, no glue needed. But this one that's coming out later, I can't talk about it too much now, but there's some cool stuff coming out soon. But for now, this guy is working. Let's put on the pressers. These are just designed to snap fit on there. These rubber things were in the original ones. Joe says, now, yeah, I understand everything. You are connecting uMyo directly to PC via the USB. Yeah. Yeah, that's kind of why, because you want it to be as close to real time as possible. Any delay is gonna hurt. It's not gonna be pleasant. That's like straight up hitting them. Yeah, that's perfect. We're gonna get the full range of motion with this one. This is actually gonna be better. Springs are also a lot lighter. The future version has a smaller nubs. Now, where is my hairbrush? I gotta put on some music. Gotta have a little bit of music going on here. Let's listen to the Fat Rat. So, Open Muscle, uMyo both connect a different way to PC. Yeah. So I use UDP packets. So Wi-Fi, okay, every streaming protocol that's like a video is UDP. Now UDP is just like, it doesn't care if the person receives it. It just sends the data, and it probably has the highest throughput that I know of when it comes to Wi-Fi protocols or networking protocols. That's what most videos are using when they're just streaming a service of some sort. But the problem with UDP is that you don't know the recipient got it. So there's some kind of checks and balances and how you kind of negotiate if all the packets were lined up and whatever. But it's really good at sending a lot of data really fast where you want it. Hopefully the battery's flipped out. Yes, yes, yes. All right. And you can't see this, but I have like a little cart behind me. Here's the battery. I gave the rubber band to my friend. So, battery is meant to go here. And just kind of do something like this. There we go. Ah. I really don't like bending these wires. Okay, putting the battery on was a lot more annoying than I had remembered. There we go. So now the battery's connected. Plug it in. All right. There we go. Okay, so it's booted up. You can tell that, ooh, yeah, this is set pretty nice. So we are going to calibrate this. So release the depressors. I programmed all this and made this. I'm kind of proud of this. Put them all down, press that, and now you can see the screen is clean. There we go. Gotta see this. It's so funny. I was impressed. I'm more proud of Open Muscle, but people like this so much. I've gotten more compliments on the last system, but so yeah, now you can see the output correlated onto the screen. So this guy uses Wi-Fi. So I'm going to turn on my Wi-Fi hotspot. Open Muscle process is simpler and can be scaled to become an app. I think both of these can. And I think that That's what's so cool about open source communities is that you can work together on stuff like this. I think it's super awesome. Okay, I got the mobile hotspot. My Wi-Fi connection is being shared. So now we're going to go and connect to Wi-Fi. So now I just scroll up to the top, connect to Wi-Fi. Connecting to Wi-Fi now. Connected. Sweet, sweet. So now it is connected. Now why the heck is Quat Math not working? Python. Import Quat Math. Import Quat Math. Oh, maybe they had it. Yeah. I think that was a separate. No wonder. It's because I deleted all the files. See, I'm such a dummy. I'm such a dummy sometimes. I knew something was wrong. No, I really didn't. I would have not figured that out for a while. I shouldn't. See, Quat Math is right here. So I have to paste it. Okay, sweet. So now, I can close all these. So yeah, USB data record, uMyo parser, and we don't have to have these two open, but the Python program uses these two, so we're going to leave them open just so we kind of know what's going on. So now we'll run this. Cool. So Pygame opened, and it says port is not defined. Yeah, port equals. Oh, no. Yeah. Whatever. Port equals 2. Ta-da! We're going to import 2 for no reason. Integer is not import. Oh. Let me look at the code from uMyo here. uMyo testing. Port equals list com ports. That's what it is. So port equals list com ports, and then we send that in there. Okay. Now let's run it. Sweet. Okay, you guys can't see this. Sorry. Okay, so now it works. So now instead of the normal stuff, it asks which COM port. This one is COM6, I know, so it's 1. Okay, 1 and enter. Name display enough. Did you mean AAA? Yeah, displaced. Oh, no way. Yeah, we are not having these display stuff. Oh yeah. So inside of machine learning tests, we are going to remove the AAAs. The only reason I did that, I was trying to differentiate it enough so that way it could be kind of merged to the other one without too much of a hassle. But I put them in a subfolder, so this should be good enough. And we'll leave that AAA. Okay, so uMyo parser, display stuff. And we have to close these. That's what I get for trying to be clever. So uMyo parser is good. Display stuff, we will have to do too. No, display stuff doesn't have anything. Okay, so now we can run this. Put COM port 6. Okay, so it's connected. That's awesome. So that means now, let's see if it will do all these. I think it messed up last time. Let's see. Okay, it's kind of showing. So what I'm going to do is turn on uMyo. If my stream just ends, please forgive me. My computer glitches sometimes when I show all these cameras at the same time. Okay, now I connected it. So these are all connected together. So I'm going to turn on one of them. And you instantly see that it shows up on the computer, which is pretty cool. And what's even more cool is when I close this program and turn off the device, I don't know why this is staying up there, but whatever. What we will see is that now data captures appears, and we should see one that we just created. Oh, wow. Should have seen a different one. Yeah, so this is me running the file. So there we go. This is the data that was recorded. So this recorded the capture from just one. So now what we have is a program that will output the captured data into a text file that pretty much is an array. It's a list of arrays separated by a character or line break. And if there is anything in the array is a dictionary object. The dictionary object is quite yeah, it is a little bit annoying because of the date time. I should have probably kept it array, but I just wanted people to more easily parse through it. It's kind of like in JSON format, which JSON, that format is really inefficient because you're sending all of the header data at all the time. So arrays are a lot more pleasing, but at least we have some working code. So I can go ahead and I'm just going to delete all except for these two. Delete all these. And what I need to do is wherever Pygame, I think it's display stuff, is in Pygame. So I'm going to open this one. And I really need to do file save. Oh, okay. I won't worry about that. So anyways, so this records it. So these files will now record, simplify machine data capture. Okay, so we're going to close this, and this is going to be record USB data. And this is going to be machine learning train. Okay. So yeah, record USB data and machine learning train. Okay. Sweet. And now I also need the data capture from the other file. Whew. So what I need is okay, my old repository. We need last capture. Okay, perfect. So now paste last capture. Okay, so this is going to be crazy. So we're going to open this Python. Yes, I'm going to allow Python access to the network by opening up a socket. Fine, never mind. So yeah, so this is pretty much running a socket for, there we go. Perfect. Run module. And this is capturing from the other one. All right. So let's go to all of them. Now I'm going to put on the bracelet. Super awesome. And start turning them on. All 4 of them. Cool beans. I have the LASK system. So now what I'm going to do is UDP send. So now I should have all of them. Yes. So what I'm doing is capturing data from both the uMyo bracelet and the LASK system. Kind of sending some interesting little bits of data. I've never done this type of data. I've just looked for the bigger signals. So yeah, this is recording both uMyo and the LASK. So I'm technically capturing as much data as I can. And I've actually, these are lighter springs, right? So I've done 2 things. I've adjusted the height of these pistons and I put in lighter springs, which is probably not going to be nearly as effective as the louder springs, but this is, yeah, this is data. So, but I can record for longer with these lighter springs. That's the nice thing. It's a lot more difficult to do this for a long period of time when the springs were as taut as they were, because it was super hard to press down. But this isn't nearly that hard. So what I'm doing is just kind of giving it each finger a lot of it and kind of some interesting Morse signals. And so 80% of this data is going to be trained on, and the other 20% is going to be used to test it. So I can kind of test and hold. Now I'm going to do the opposite, is lift off on these fingers, which is hard to do. I play a lot of guitar, and this is not easy. Okay. I don't necessarily like that. There we go. Now we're back to some normal movements. And so now I'm gonna, this is probably the 20% that it's going to be seeing. And I kind of like this stylized thing. Okay, come on, come on, come on. And we're gonna stop. This is cool because this is not difficult to do. So all I gotta really do is just close these, and that's pretty much done. So I'm gonna turn these off one at a time. And disconnect the battery. All right. So the LASK recording and the uMyo recording are separate. So I'm going to do file.close, even though it will not matter. I'll do the same with the other Python instance. File.close. Oh, no. That was the same one. Yep, file.close. Perfect. Okay, we can close both of these. So now if we go into data captures, we should see two. We're not going to see that because one messed up, but let's hopefully. Oh no, you gotta be kidding me. Oh, looks like the data failed. It didn't write it. Oh, come on, come on, come on, come on. Well, yeah, we're doing it again. Let's try this again. So, well, it's not ideal, but it happens. It happens. Every once in a while, something doesn't work. So let's just test this. So run module. Yeah, and close. File.close. Okay. Show more options. Refresh. Huh. Oh. No. Hmm. Why is that other file not showing up? Yeah, file lock close. Hmm. Yeah, we don't want uMyo testing. Oh, was I using uMyo testing? That's probably why. It needs to be record data USB. I might have not been using that one. That's okay. So we'll run this. Run this. Okay. And come on. Come on. Show me the other one. Stop being silly. One. There we go. There we go. There we go. Doing it again. It's okay. Gotta do it again. Which is fine. These springs have been changed, so it's easier. So hopefully it won't be as difficult. Do fingers two at a time because this machine learning can actually detect two fingers at a time, which is kind of funny. Individual fingers, multiple fingers. It's pretty cool. The 3D6 did an analysis on it, and if you're going to use it for Boolean finger prediction, you can get like a 98% accuracy, and that's only with about 5 minutes of data. So yep, this is how I've been training the model. A whole bunch of these. It's kind of cool that you can see in the model or the data. Here, you guys can see it up close if you want. I was just kind of doing the other screen, so What's kind of funny is that the LASK system uses magnets. I wonder if it throws off some of those magnets there. Okay. The last bits are usually done. Okay, then we can close this. There we go. All right. Now I can turn these off. Actually, before I turn them all off, let me make sure. Yes, 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 yes. Oops. No. There we go. I also I turned one of the uMyos to a different color on accident when I first got it, and I thought it was broken. And I was like, "Oh, I didn't want to tell anyone it was broken, but it wasn't. I just turned it into the different mode because the different colors that they're in are in different modes like so yeah. So let's look back here. And so yeah, this one's pretty much done, so I'm going to turn it off. And then it's good to go. And then I can tell the batteries are low on this one, so I need to charge it. So I'm going to charge it since I'm not using my microscope. And I go ahead and charge it this way. Right? Yeah, this should be charging now. All right. Okay. So now we have the last capture 2, the last capture 4. So yeah, the 4 is the one that we want. We're going to delete this one since we don't have a companion pair to it. And we are going to call this uMyo week springs 23 923. Try again. Okay, it's try again. There we go. And this is gonna be last week springs 923.txt. Okay. So we will open. So I wrote this. This is my little mini algorithm to set this up because I have a preferred method of filtering packets, and it's very unique. I don't know if anyone else does it this way. I don't mean to say it's unique. I'm too lazy to search to see if anyone else has done it this way. But I'm going to say this again. I like using regressors when you have data that's variable output. Classification doesn't make any sense to me for the raw data of muscle signals because inherently it's a regression problem, not a classification problem. So I like to approach this from a regression standpoint so that we have a variable output, not just finger moving or finger not or some kind of hand gestures in a certain way, but rather it's moving toward this direction. So how you do a regression is you give it the feature data and then the label data. Right? Well, so what's a regressor is a type of model, but in a regressor, let's say I'm using 12. So right now I'm going to be using a whole bunch of data points, like 15 data points on the feature data, and then 5 data points on the label data. Now the label data includes the time domain, and I do this on purpose, right? Because machine learning is statistics. It's pretty much looking at the most statistically likely calculation that the algorithm or the model can make with the highest accuracy, depending on its method of training. So when you're looking at the slope, do you offer paid serve for editing signal classification desktop app? No, I don't sell anything. So when you have the data points, when you're trying to look at the statistics or look at data, you really want to know the curve, right? And the curve will tell you a lot of information. And how you calculate the curve is based off of the time data. So a lot of times in machine learning, I like to put the time domain as a variable, and you're in danger of actually making the model learn at a certain point in time in memory when you don't really want it to have memory. But I've seen the results, and this works. So I add the time domain mostly so I'm giving it enough information to properly calculate the slope. And that's why I really think that keeping the time in there is not a bad thing. I think other people have said that this is a bad thing, but I'm producing good results, and so I don't see anything wrong with it, and I enjoy it. And I haven't memorized a signal because it's not memorizing something at a point in time. But I don't. But I can. There are some softwares out there, but I don't know quite what you're asking though, Joe. Do you offer paid service or serve for editing EMG signal classification desktop app? I don't know. I don't know what that would be. Okay, so this is the packet filter. So what we're going to have to do now is we're going to have to line these packets up, right? And this is what I have here. So I'm using the time domain with each sensor. So it's going to match these pairs within the closest time that all the packets come in to the best of its ability. And it's going to try to match them, and it's going to output a CSV file. So what I have to give it is the input data. So F2, Control A, Control Copy. This is for the LASK. Okay, F2, Control A, Control Copy. And this is for the uMyo. So now what this should do is filter the packets. No such file or directory. Oh yeah, oh my goodness, I hate the fact that I did this twice. I did this to myself last time. Yeah. Yeah. Oh yeah, I need to, wait. I think I can comment these out. Oops, come on. What the heck? Oh my goodness, this is so annoying. I was up. Okay, let's run it now. uMyo. So annoying. So, yeah, this is just stupid. I don't know why I did this. I need to clean up the code. Let me just look at this and clean this up for the time. So, why the heck print? Yes. I don't need any of this. Control X, Control X, Control S, F5. Thank you very much. Okay, that worked. So let's see if it, okay, it did. So what it did is, yes, comma, okay. So what we need for scikit-learn, because we're using scikit-learn, is we're going to need to give it a table. And it has to be a two-dimensional table. And each row has to contain all the bits of information that we want to give it. Right? So what I did in that last algorithm is I filtered all the packets to try to filter them up to the closest possible. So for example, we can see U3 time, U0 time, U1 time, and these QGS are the filtered outputs. So yeah, that's good. So we close this. This says September 13, best CV. Sure, why not? Okay. So now we can do the machine learning. This will be kind of fun. So we're going to do machine learning for what we just did, right? So now I opened up machine learning train, and it's going to take in the data file from captures data file. Did I label it 14A? No, this says best. So this is not going to be that. This is going to be September 26. And then going to put week springs. Okay. F2, Control A, Control Copy. And I'm going to paste in that file here. So now we're going to do machine learning. We just run this. So I did this kind of quick. So it's asking what the data file is. So since this is the new data file, that's what I'm pressing in here. When I modified this code just works. You do have to kind of type in these variables. It'd be nice if it just kind of popped up on the screen. And I am working toward that, but we're not there yet. So now let's just run to see if this code functions. And it should hopefully even save the output too. So right now it's going to train it. So let's take a look at the code while it's doing it on the right side. This should take 5 minutes or less. So we're using scikit-learn, and we're importing some logistics regression, some accuracy scores, random forest regressor, which is our model type. Mean squared error, mean absolute error, that's to help to analyze the data. So first I'm using pandas to pretty much grab the CSV file, because pandas is really quick at reading the data. And I'm telling it the input features. So this is just the first part of the row that has the feature data, right? And that's going to be X. And then I give it the label data, which is the right side of the row. And then that's as Y. And then what I'm doing here is I'm taking the data and the test size after it is training, and I'm going to run some stuff on it. So this can train off of the 20%. And I think I set this up correctly. Let me double check. Yeah, and we train it. Okay, so once it's done training, it's then going to save the model as a pickle file, right? And it's going to then predict and evaluate the predictions. And this is kind of the same way that you would actually run in the live data when you're using the model. So in OpenMuscle, I also gave the example of having a real-time predictions, and that shows up, and it's not quite real-time. I actually have to strip a fifth of the packets. Actually, sorry, I have to strip 4/5 of the packet data in order to make it close to real-time, but it works, which is kind of hilarious. So not only does it predict, but it predicts with 1/5 of the data, right? So it's just setting in snapshots, and it's almost doing classification with regression, which is kind of stupid. But how crazy good it is at predicting the 4 finger movements, and soon to be 5, it's just insane. When I saw that, I literally thought it was magic, and that's what machine learning is quite cool. And I did not believe the results even after I had the data, because I was afraid of this one line of code. Okay, so this one did a very poor job, because the mean absolute error was 236, but that's okay, because we want that close to 20. That's about 10 times higher than I'd like to see it, but it still worked. And since we have about 1,000 or 500, I'm not sure. We'll take a look. So it's machine learning, and yep, now we have our model, and our model is 130 megabytes. And now we can take a look at predictions versus actuals. And for that, to take a look at the data, I'm going to open up Sensi ML. I think maybe. Yes, maybe I will. Oh, and I was going to play some Fat Rat. Here we go. Much better. Okay. And then we log in real quick.
Come and fly away with me.
Oh, yeah. So what we have
Come
to
and
do
fly away with me.
first
Come and fly away with
is
me.
open this up, and we're going to have to sort the
Come and fly
data.
away with me.
So this is predictions
Come and fly
versus
away
actuals.
with me.
I don't
Come
know
and
how
fly
to do
away with me.
save. Because it was using random. Keep current format. Awesome. So now I'm gonna go to uMyo and SensiML. And from here, oh good, you could kind of see my email. It doesn't matter because it's one of my scratch emails, but here we go. So now we're going to data manager, and we are going to import capture, and I'm going to choose that, documents, machine learning test, predictions versus actuals 5. Oh, crap. I'm going to rename it. Why can't I see my mouse? Yeah, this is going to be week spring test. Okay, we're going to pop it in here. Confirm import. So here is the data. Predictions versus actuals. So this is not nearly as good. Oh, let's zoom in a bit.
Something's gonna bring the change. Journeys we are meant
Yeah, so this is a
to
lot worse. It usually looks a lot better. But here's an example of all fingers right here. So it turns out the weaker the springs, the less effective this is. But you see the 4 fingers being predicted quite well right here. And there's not as many data points, so it looks like my algorithm might have messed up a bit. Yeah, and these changes are pretty harsh. I'm thinking I messed something up, because usually there's way more data points. So I need to focus on my algorithm. But you can definitely see, since all these lines are close to one another, they are. Let's look up last time. Let's look up one finger. Okay. So how do I get it to refresh? Like refresh probably doesn't work. No, it doesn't. How do I get rid of? Looks like they're still working on this. Maybe? Do. Okay, I'm bored. Not bored, but let's look up the data in this program. Okay, this is easier. So let's take yeah, actual last. Just take a whole bunch of them. Okay, and let's insert a graph. How do we do this? Okay, I want a line graph. Yeah. Alright. Next. Data range, data and columns, finish. Okay. Yeah. So actual one is blue, so I can't really see the data too much. There's a lot of blank at the beginning, so we're gonna wait till 75. Okay. Just get rid of this. So let's go to 100. I'm just gonna delete these. Delete this many. Delete. Actually, delete all. Delete all. Okay. What? Delete rows. There we go. I don't know how to do this properly, so whatever. I need a diagram. Okay. Line. Da, da, da. Yeah, we just need the lines only. Okay. Much better. So last one is blue and light blue. Yeah, so these are pretty off, and that's again probably mostly because I used really weak springs. So there was no real clear signal, and this was just a test I needed to run. So I really reduced the springs by like an infinite amount almost. Not really, of course, but the springs are next to nothing right now. So the next step is actually to get the code a little bit better. So these springs are super weak, as you can see how quick this is, as opposed to this guy, which was what the one I was using before, is much stronger, and it's actually slower to do these and get a lot better data. So I need to change this out and work on the code a little bit more, but I think that is enough for today. I didn't get to the NRF 24, but we'll do that soon. So at least I refreshed myself with the code, and since this week I'll be working with the code quite a bit for uMyo, it's good to have kind of a refresher, how things work, kind of poke it a bit, as they say, kick the tires in programming. But we successfully trained a regressor model on a labeled data set from uMyo, and it did predict it, but since the signal was so weak and it wasn't for very long, it didn't correlate much of the data. And plus, I do believe that my data points are lacking. I think my algorithm messed up in the code because usually I'll see like at least 20 data points for a finger curl. So I'm going to have to go rectify that and see it. So it's all a part of kind of getting the process down. I'm using MicroPython. I'm using kind of a hodgepodge of technologies to pull these together. So some of these tests work, some don't. And I just kind of take note of it. I haven't actually delved into the data acquisition because there's some stuff I have to work on before then because it's good to write code that makes it easy to use. So once I set those things up, we should be able to record 4, 5, 6 different sessions, throw those all in together to one file, and then we can train the model off of all that data together. It would be fun to assign different value outputs based off of the spring tension. So you could have one level be less than the other. We could do some calculations for that. That's a possibility to do as we change up the springs. We can use not the Wi-Fi protocol. Also, as you saw, the screen lagged when the packets came in to the computer, and any type of desynchronization with the data packets can lead to the model not predicting accurately, which is also another error. And that's one of the problems, is that you can run into a myriad of all these different errors, and that's why oh my goodness, sometimes it can get frustrating. But you do it enough and you keep on at it, and then finding one problem at a time. And that's why I like to see a complete cycle of the code, right? So we were able to capture the data, to filter the data, to train the data, and then look at the predictions and using all the systems. And I think that's very helpful because there's 1,000 things that can go wrong. So that's enough for today. I hope you guys enjoyed this. It is a little bit boring, but I will try to get some videos for you guys recorded on the specifics as the actual code gets released. And then I should be able to send a pull request to Ultimate Robotics, and maybe we can get some of this stuff added. But we are waiting on some cool stuff that I will be excited to share later, but now is not the time. So I'll leave you guys with the same thing I always say, which I truly believe is, let's see if we can make a positive difference in this world. Till next time, and thank you so much for watching, guys. Please like or subscribe.